Recording has begun. So today we're going to discuss three topic areas, time permitting, three topic areas that were mentioned in your submissions. One of you submitted mixture problems, okay, and I do see you in the participant list, so there you are. Mixture problems are actually a subset of this. They're actually a subset of rate, time, distance style problems. So you'll get that addressed today using our my trademark 7-step method here. But we're going to start with coordinate geometry. A couple of you actually brought up coordinate geometry as a submission. So we're going to start with a discussion of coordinate geometry, which is a couple of you said that you thought it was a little bit undercovered in the 9-session course. You may have a point there. It has been increasing in importance, so it's a worthy topic for today. But then what we're going to look at is what I call decoding prompts for critical reasoning. What that means is a lot of the time, because we like to classify critical reasoning problems into these nice little boxes, like find the assumption, draw the conclusion, things like that. But as a lot of you have noted, and as a couple of you emailed me about, sometimes the prompts are not as conducive to those categories. Like sometimes you get a prompt that doesn't say find an assumption, and it doesn't say weaken or strengthen, but you still have to infer that that's what you're talking about. So that's also an issue, and that's something that we'll get into in decoding CR prompts. And then finally, the end of the session, whatever time we've got left, we'll look at rate, time, distance, and all of the problems that are offshoots of rate, time, distance, such as mixture problems and hourly wage problems and so on. There are quite a few problems that are related to those that can be solved with the same sort of methods. So, all right, give me the smiling face if you guys are ready to go, if you're ready to hit it on coordinate geometry here. Okay, so let's do it. Coordinate geometry is an interesting animal because most areas of the Quant section have more or less unique modes of solution, where you see a problem, and at least if you know the subject area fairly well, there's like one sort of canonical way of solving these problems. With coordinate geometry, on the other hand, it's not the case. And with coordinate geometry, there are actually two different canonical modes of problem solving. Canonical meaning like the textbook method. If any of you have sat in on my classes, you'll know what I mean by textbook method. But in other words, we're talking about two different textbook style methods of solution. One of those methods of solution is algebraic. This is probably what most of you are more familiar with. So for instance, algebra usually centers around the equations of lines, which type in the text box, what is the canonical equation of a line in the coordinate system? Go ahead and type that in the text box. A couple of you. Okay, we're starting to see that there. Yeah, okay. So e.g., the center of all of this stuff is usually the equation of the line is y equals mx plus b. You know, but also there's things like slope formulas where you have slope is y1 minus y2 over x1 minus x2, and then you have distance formulas, and you have, you know, etc. And then you have like perpendiculars. If you see perpendicular, you have opposite reciprocal slopes. These are all algebraic methods. And I'm sure that most of you at least have some sort of familiarity with these algebraic methods. On the other hand, as you probably know, this exam is, one of the central purposes of this exam is to separate people who just sort of memorize their way through everything and try to use memorized protocols all the time from people who can use multiple strategies and sort of unusual and innovative methods and conceptualizing things. This test is meant to favor the type of student who conceptualizes things well. And so as a result, in addition to algebra, there's another approach. Does anybody know how else they want you to be able to think about coordinate geometry problems besides pure algebra? Does anybody know where I'm going with this? Okay, right triangles are one thing you might see, although again, you could do algebra with right triangles, or you could what? The triangles. Instead of working with algebra, you could see if you could visualize them. The other main approach is visualization, and then poster who said right triangles, maybe that's what you were thinking about, seeing pictures of right triangles. So for instance, instead of seeing things as formulas and coordinates all the time, when we talk about visualization, we're talking about imagining possibilities. We're talking about imagining restrictions and imagining freedoms of movement on the coordinate plane. So let me give a couple examples of what I'm talking about. But the deal is that these are two totally different methods. They have very little in common with each other, actually, and so they're basically alternatives to each other. So here's an example of the difference between algebra and visualization. Let's just say I give you something like this. Very innocent looking statement. The slope of line N is 2. Okay, that's N is going to show up there in a second. There's N. So let's talk about what this means in terms of these different approaches. Okay, in terms of pure algebra, what does this mean? Give me one algebraic interpretation of this in a text box. If the slope of a line is 2, what does that mean you can do? It means that you can plug in, so that's one thing. One of you guys put 2x plus 5, where I'm not quite sure where you got that 5 from, unless that's supposed to be an example. So, but right. So algebra means you can plug m equals 2 into y equals mx plus b. So that gives you y equals 2x plus b. Up to and over 1, that's actually a visualization thing. We'll talk about that in a second, but good. So whichever poster said up to and over 1, you're a step ahead, but we'll get to you. Another way, so that's one interpretation right there. Another interpretation you might have is the slope formula itself, where if you have 2 points, then you can say y1 minus y2 over x1 minus x2 is equal to 2. But then in terms of visualization, we are looking at totally different things. So there are these 3 components that we looked at on the previous slide, possibilities and appearances. So let me add that over here too. Imagining possibilities and appearances. So what is the appearance if you have this? Well, it's a positive sloping line and the slope is greater than 1. So we'll get to this in a second, but the line has to look like this, roughly speaking. And it's not just anything pointing up and to the right. It's with that exact sort of slope because, as one of the earlier posters pointed out, for every 1 unit this line goes over, it has to go up by 2. So up 2 units for each 1 over. That's what we mean by impedance. We had 2 more factors to think about, which are restrictions and freedoms of movement. Let's talk about what we mean by that. Freedoms of movement. If I take, let's say I take a coordinate system, and I put a line with slope 2 on that coordinate system. Let's say here's a line with slope 2. In the text box, what can I do with that line such that I'm moving it, but it still has a slope of 2? What am I allowed to do with a line that won't change the slope of the line? Anybody know where I'm going with this? Again, it's a vague sounding question, but it's going to be attacking. Yeah, you can change the y-coordinate. Be careful what you mean by that. It depends. It depends on the y-coordinate of what. But yeah, you can move it along. You can slide it. So you can take it and you can move it here. You can move it here. You can move it here. You can move it there. You can move it all these places. You can slide it up and down. So let me just replicate a few other versions of that. You can slide it horizontally. I mean, you can slide the line around the plane. Smiley face if you guys see what we mean by that. Okay. And then, yeah, the smiley face you can also put in the text box if you want. But when I say smiley face, I'm talking about this icon that's over there on the left. There's a little button you can press. It looks like a smiley face. When I do call for smiley faces, if per chance you don't understand what I'm talking about, you can click the other button, which is the kind of bamboozled-looking face. It's got the weird-looking mouth that's kind of looks like it doesn't understand. Yeah, that one. Okay, so finally, there's restrictions. What you can and can't do. In this case, you can't rotate the line. Because if you rotated the line, you'd be changing the slope of the line. I mean, my point is here, there's 2 points. The first is these are all takeaways. Like when you see the slope of a line is 2, all of these things should in some sort of order come to mind. But the main point I'm trying to make here, aside from you should know all these interpretations, is also that notice how different the approaches are. I mean, notice that the stuff that's over here has almost nothing to do with the stuff that's over here. These are completely different interpretations. So what your challenge is to try both of these methods in order to solve coordinate geometry problems. In other words, if you try one of them and it doesn't work or it's not yielding results, you should quit and try the other one. Which one do you think you should try first and why? And before you answer this, let me tell you a fact. The fact is that there are about equal numbers of problems that use these methods. In other words, there are roughly the same number of primarily visual problems as there are of primarily algebraic problems. So like if there were a huge preponderance of one or the other, like if there was 4 algebra problems for every visual, then you would definitely do algebra first and vice versa. But they're about the same. So given that, does anybody know which one you should try first and why? Yeah, so what we've got on there is, yeah, visualization because it is less time consuming. So I don't want to use the word easy because easy is different for each person. Like if you are, that's not a very well defined word. Like if you're very much accustomed to doing algebra, then you may find algebra easier. But if you're very much more of a visual person, you may find, so I don't want to say easy. But you should try visualization first. A couple of the posters have hammered this right in the head. You should try visualization first because if it works, it's usually very fast. You guys know this. Algebra can be a very time-consuming dead end. Like if you're doing algebra that doesn't get you anywhere, you can waste unbelievable amounts of time on it. But with visualization, it's kind of either there or it's not there. You either know what something looks like pretty much in a matter of seconds, or you don't know what it looks like. So attempting a visual approach is not going to consume a whole lot of time. So this is a good way to begin. So let's try some problems. I'm going to give you 2 data sufficiencies, which involve coordinate geometry. And we are going to, I'll give you maybe between 3 and 4 minutes to solve these problems, and then we'll go ahead and have a discussion. In fact, what I'll do is I'll give you one of them at a time. So give me a quick second here to put these on different whiteboards, and we'll be on our way. Okay. And almost there. Hold on. Apologies. Sorry about the wait. Okay, we are good. Here's the first problem. Give this a shot. I'll give you, here's the way this works, by the way. Do not put answers in the text box. Do not put answers in the text box. Okay, in about 10 seconds, you'll find buttons at the top left of your window. So those will be at the top left of your window in about 10 seconds. So here they are. Okay, A through E multiple choices are on the top left of your window. So I'll give you about a minute and maybe a half minute and 40 seconds. Go for it. Okay, in the next 15 to 20 seconds, everybody try to get some sort of answer to this question, please. Again, the buttons are in the top left. You should see an A, B, C, D, E towards the top of your window. Go ahead and click something, please. Give you about 10 more seconds. We're waiting on Reka, Layla Z, and CH3, and Abba. Layla Z, I think you had an answer up there before. Okay. 2 people, still no answer. Let's try to get an answer, please. Remember, on the GMAT, you have to answer the problem, so it's good to have to get into here. Okay, 3, 2, 1, let's cut it off. Here are the statistics of your answers. These are what you guys picked. So as you can see, this problem was apparently a rather contentious issue. Let's talk about this. In the text box, let's talk about how you guys approached this thing. If you used a visual approach or algebra approach? Go ahead and tell me in the text box which type of approach you guys use. Let's kind of take a survey here. Okay, so it looks like most of you are visualizing it. That's good. Because quadrants, this is kind of a tough question to answer with algebra because there's no plugins for this question. So let's try visualizing. Remember, we teach that you should address the easier statement first. Statement 2 is probably easier because it's easier to visualize a point. Points are easier to visualize than slopes. So let's do statement 2 first, and let's use the BDACE chart. So y-intercept of line M is -2. Well, let's draw a picture of that. So here's statement 2. That just means that you have, at this point right here, you have a dot. You have a y-intercept. And you have to have a line that goes through that dot. So you need a line going through this dot. What freedoms of movement do you have for that line? Text box, what are you allowed to do with that line? Yeah, Amanda's got a good way of thinking about it. 360 degrees, you can pivot it, you can rotate it. It's not anything in the world. It's not totally unlimited, but because you can't slide it, but you can rotate. Right? So you can rotate, but you can't slide. So here's the possibilities. You've got to have some lines that are like this. You can rotate it. You can draw any line you want that goes through that dot. So the second quadrant, by the way, the GMAT will probably tell you where the second quadrant is. But the second quadrant is this quadrant up here. So notice that some of these lines go through the second quadrant and some of them don't. So some hit the second quadrant, some don't. So this is a maybe. This is insufficient. Smiley face if you guys follow that. Okay, I've seen a bunch of smiling faces. Okay, good. Now let's go with statement 1. Statement 1 is a negative fractional slope. So you need to make sure that you know what a negative fractional slope looks like. So negative fractional slope, what does that look like? See if you can describe it in the text box. If you were all standing in front of me, I would just have you hold up your arms in the right orientation, but we can't do that here. So try to describe that. It's downward sloping, and yeah, it goes down only 1 for every 13 that it goes over. So it's a very gently sloping line, like this. It's a very gentle downward slope. So, yeah, the backslash in the window, that's good. Let's talk about freedoms of movement. You can slide the line, but you can't rotate it. So in other words, you can take this line and you can make it, you can slide it down like here and here and here. But yeah, tell me about these lines. I mean, remember what it does. Like it's going to go over 13 for every 1 that it goes down. Or sorry, for every 1 that it goes down, it's going to go over 13. That's what a line of, that's what that slope means. So this is 13 if this is 1. But notice an important fact about lines, which a lot of you guys are sort of neglecting here, is that lines don't stop. Lines always are of infinite length. That's what a line is. If it stops, it's called a line segment, not a line. So these guys are all going to eventually make it into the second quadrant because every 13 units they go over, they go up 1 unit. So even if your line is all the way down there, like 1,000 units below the x-axis, if you went over 13,000 units that way, you would get there. You're eventually going to make it into this quadrant, no matter what. All of them will, if you follow them leftward enough, they will eventually get up there. All of them will eventually get into the second quadrant. Smiley face if that makes sense. And any takeaways that you might need from this problem. So all of these are going to make it up there. This is an extremely, extremely obnoxious problem to do with algebra, to the point where it's almost impossible. And within 2 minutes, it's especially obnoxious. So this is a yes to the question. So this is sufficient. And so we have the final answer, which is which is A, like Alice in Wonderland. There you go. Okay, I noticed one of you is typing what, I don't know what you're typing, but it might be a question. Is it correct that you can answer? There's a post there. I think you guys can see the question. Give me a smiley face if you can see the question in the text box, so that I don't have to reproduce it. Okay, the question is, like, if you're, so basically the question, as my understanding, Tyler, you can give me that frowny face if this is not true, but my understanding of what you mean here is that you're asking whether any slope and any quadrant will still be sufficient. Is that what you're asking? Smiley yes, frowny no. Okay, no it won't, because for instance, let's look at these lines right here. If I ask you whether these lines are going to intersect quadrant 1, which is over here, then that's a maybe. Because the ones that are down here won't. These will never make it up there. But the ones that are up here will. So the full situation, this is very visual in nature. Once you see it once, you should realize it. But the negative slopes will always hit quadrants 2 and 4, these ones. But we don't know if they'll make it into these. The positive slopes will always hit 1 and 3, but they may not make it into 2 or 4. They may not. Okay, if you have any other questions about this problem, go ahead and type them into the text box. Otherwise, we've got another one for you, which is even more fun than this one. Okay, I'm going to clear your answers out of that box. If you guys are ready for a really screaming good time, try this. This problem is sort of obnoxious. Oh, by the way, actually, before you do that, sorry, I don't mean to spoil the fun here. Let me make a point about this. Okay. A lot of you guys picked choice C. Yeah, the question in the text box, the answer is yes, that would be C. A lot of you picked C. Remember the way they designed these questions. Okay, basically the specific purpose, in order to help you guess, Okay, part of this test, I mean, remember the specific purpose of this test is to separate insight or genuine conceptual understanding from mere memorization. Or like naive guesses. And what I mean by naive guesses, not, I mean, you know, like the naive guesses is like the way that somebody would guess after seeing this stuff for like a day in school. Okay, so someone who just memorizes or who has only seen this stuff for like 1 or 2 days would think. They would say, statement 1 gives M, statement 2 gives B, so I have Y equals MX plus B, therefore I'll pick C. And I think this is probably what most of you were thinking, those of you who picked C. What you've got to realize is that the test is explicitly written so that it will kill you if you do stuff like that. The explicit purpose of this exam is to make sure that these sorts of methods fail. To the point where if you see them handing you a slope and handing you a y-intercept, you should actually be disinclined to guess C. Right, that's a very profound thing. But that's a trap answer. Okay, they're trying to get you to look at this and say, oh, slope, y-intercept, I'll pick C. That's their purpose here. They're specifically trying to filter out people who will just guess based on an equation. So it's actually to the point where if you weren't sure on this problem, you should be very, very highly suspicious of their just handing you these things on a platter. Okay, there's a question in the text box about difficulty level. It's kind of pointless to answer that question because you're not going to know difficulty levels on test day. So it's the answer to that question is useless to you guys because when you're looking at a problem on test day, you're not going to know. So the point is, though, this is if you are guessing. I mean, if you know what you're doing, like if you clearly know that you're correct, then you should pick the answer. But I would wager that most of you who thought the answer was C were guessing because it's not C. So if you were guessing, you should guess away from answers like this because that's what this test is all about. And I mean, you shouldn't be worried about these so-called difficulty levels because, you know, if you're guessing on a problem, it's probably pretty hard. So, okay. Let's move on to something else. Remember what we said, though, about if you have to guess, remember how you should guess. Okay, let's look at another problem. I noticed a couple of you are typing some questions, so I guess I'll wait and see it typing. The answer to that problem was A. A like alligator. All right, let's do it. There's another problem. This one's especially fun, so I'll give you about their question. I answered that question. The answer is yes. Okay. But they probably won't give you that question because the naive guess would be correct. So the reason the question is what it is because that is incorrect and the naive guess is incorrect, and you have to figure it out. Okay, here's a new problem. Give us a shot. I'll give you 2.5. Actually, I'll give you 2.45. Let's go for it. Okay, the clock's running down, guys. So we're pushing almost 3 minutes here. So make sure to guess something. Still lots of blanks. I count like 6 or 7 blanks right now. This is the GMAT. There's no such thing as blank, so please answer. And this is the 3-minute mark, so you just can't be spending more time on this. So those of you who have not guessed, looks like Rekha and Layla Z, CH3. Okay, here's the statistics. There they are. All right, so still a lot of controversy. We have every answer choice represented here. Well, let's talk about it. Let's say we're guessing. Okay, so we'll put the let me copy this to the next board. Let's say that we're guessing on this problem. Say, because I'm sure a lot of you did. This is not an easy problem. So let's say you had to guess. Okay. Well, if you have the two statements together again, statement 2 is B. Statement 1, once you have B, is M. You should be suspicious. Because it's the same sort of thing we said last time. This is still sort of the wide-eyed, innocent approach to the problem, where someone who's just learned about this stuff would be like, oh, hey, I got the y-intercept, and once I plug that in, I got the slope. It's very simplistic. So that doesn't guarantee that C would be wrong, but if you're going to guess, you should probably navigate away from answers that are like that. But also, note that E is impossible. Does anybody see why E is impossible? There were quite a few answers of E, by the way. I mean, E was one of the most popular answers. Like, if you look at the statistics. So, yeah, I think, okay, I mean, worst case C is possible. I think you have the right idea. The reason why is this. Because what E means that the two statements together are still not sufficient. Okay, I mean, remember that, let's write that on the board just to make sure you're staring at it. Remember, E would mean that it's still maybe, even with both statements. Well, if you have both statements, let's look what happens. If you have both statements, then you have the y-intercept is 2, -2, and the slope must be -8. Right? This is one line. The equation would be y equals -2x minus 8, -8x minus 2. So the answer is either, I mean, therefore there's one answer. Sorry, it's not maybe. This is not a yes or no question, so it's not maybe. It means still multiple values. Well, if you have one line, you're not going to have multiple values. So even if you don't really see what's going on with these statements, you can still pick up on this. You can say, look, if I have them both, then I've got a single line. It has a slope of -8 and the y-intercept is -2. Since it's a single line, it will have exactly one y. It'll have exactly one x-intercept. So that would be sufficient. So there's no way that E is the answer, because E would mean even with a single line, you've got a bunch of different x-intercepts. So let me know if you guys follow that. Because quite a few of you, especially those of you who's picked E, I'm going to be looking at your smileys. So let me know if that makes sense to you. Okay, most of you, there's one or two of you guys. Okay, good. All right, now let's go back to what's really going on in this problem. Because this is just guessing mode. This is just a guess mode, right? Let's talk, in fact, we're not even done with strategic guessing. Let's do the strategic guessing. Well, statement 2 is insufficient. If you don't know why, we'll cover that in just a second. So BD is going to, it's basically the same statement 2 we had last time. BD is going to be gone. E is impossible. And C is suspicious. It looks like a trap answer. And so you would want to guess A. Because A is the only choice that doesn't ring off some sort of bell in your head of suspicion or is not downright impossible. So let's go back and solve the problem for real, but give me a smiley face if you guys appreciate this sort of guessing here. Because, I mean, a lot of people, especially those of you who are still relatively high scorers, you fall into these traps of being too algorithmic. And the traps that they're deliberately setting for you. Like when they say, hi guys, I've got a y-intercept and I've got a slope, they are just trying to bait you into guessing C. That's the whole purpose of that question. So make sure you know that. That's how these guys operate. I mean, it's one of the ways in which they're tricky. There's not a lot of things that are tricky about this exam. There are lots fewer than you might think there are, but that's one of them. Now let's solve the problem for real. If you go ahead and tell me in the text box whether you used algebra or whether you used visualization. Well, you try visualization, right? I mean, okay, statement 2 you can visualize. Let's do that first. And I mean, I like the answer that Priyanka's giving there in the box. You can totally flip back and forth between them. The y-intercept, statement 2 is the y-intercept is -2. Well, that's just like a point again. There's no way you're going to know what the x-intercept is. So, because it's the same set of lines we had in the last problem. I mean, it could be this one. It could be this one. It could be this one. I mean, there are lots and lots and lots and lots and lots of different x-intercepts. So there's 4 different x-intercepts right there. So that's not going to fly. Lots and lots of different x-intercepts. So BD's out. Statement 1, though, it's not supposed to say act. It's supposed to say A. Okay, so BD is gone. Statement 1 you can't really visualize because these are not really comparable qualities. I mean, you can't really visualize this because slope and x-intercept are not visually comparable qualities. You know, it'd be like me saying that okay, like e.g., if I say something like this, I am twice as tall as my cousin. Okay, this you can visualize. But if I say something like my height in centimeters is about twice my weight in kilograms, you can't visualize this. Because those aren't comparable. I mean, you can't visualize a comparison between height and weight unless you actually think about specific numbers, which is not the point. So you're going to be forced into doing algebra. Because if you try to visualize this, you will probably find rather quickly that you can't. And if anybody disagrees with me, you can feel free to type in the text box how you visualize this. But I don't really see any relatively straightforward way to do that. So let's try algebra. Let's try algebra. Well, notice that they're being really, really, really nice to you. They're giving you slope, and they're giving you y-intercept. And those are exactly the two quantities that appear in mx plus b. So this is m, this is b. So that means you have a substitution where m is 4 times b. So make the substitution, m equals 4b. Once you do that in the text box, what does your equation look like? Yeah, you plug in for m, so the equation becomes, you take m out. Someone wrote mx plus 4b. That's not correct because you can't take out b and replace it with 4b. You have to take m out and replace m with 4b. So let me do that in color just to make sure, because one of you there's a couple of incorrect substitutions on there. Here's the m. Right now that's m. You have to take out the m, not the b. So that's y equals 4bx plus b. I'll put that in different color. Let's put that up there. Okay, there's your equation. Now you have to know what x-intercept means. Okay, again, x-intercept visually means where does it literally hit the x-axis. That's what x-intercept visually means. Who knows what x-intercept means in terms of algebra? Text box. It means you set y to 0 and then you what? It's not just y to 0. You set y to 0 and you solve for x. So make sure you know that. If you don't know that, make yourself a flashcard. X-intercept means set y to 0 and then solve for x. So let's do that. That means 0 equals 4bx plus b. We factor out, so that's 0 equals b times 4x plus 1. Notice that either of these factors, well, the way you have to do this is you have to set the two factors to 0. So you set that factor to 0, or you set this factor to 0. So it looks like, at this point, it looks like either b is 0 or 4x plus 1 is 0. 4x plus 1 is 0 would mean x equals -1/4. Do you guys think these are both possible? If anybody thinks that one of these is not possible, then go ahead and explain why in the text box. Yeah, good. Okay, so if B is 0, would mean that M is also 0. That's a horizontal line, so not allowed. Because remember, it says non-horizontal line up there. So that means, therefore, the x-intercept must be 1/4 no matter what, and so this is sufficient. Single answer. It's kind of neat. Sufficient. So this is actually A, like alligator. Notice if you are sort of a guessing ninja, you can actually guess that just by being suspicious of C and knowing that E is not possible. You would be guided. Did anybody give me a smiley face if any of you actually guessed A based on this sort of advice? If any of you did that, go ahead and give me the smiley. Any of you guys with A. If not, if you guys, oh yeah, so good news. I see a couple of smiley faces. Because that's how this test is engineered. I mean, really, like a lot of the time you guys can, really it's a lot like being in an interview. Like there's two ways to do really well in an interview. The first way is to have really good answers to the questions. But the second way is just to kind of understand the person who's interviewing you and kind of get an idea of what would click their little buttons and say it. You know, you just game the person that you're interviewing instead of giving the right answer. This is kind of like that too. I mean, one way is to actually be able to solve all the problems, but the other way to do it is to be able to understand how they write the test. And if you do, you'll start to get certain inclinations about these problems. Yeah. What do you mean by checking the guess? Person in the text box. I'm not quite sure what you mean by that. I mean, a guess means you're not checking it, right? A guess means you're just guessing. Yeah. Okay, and you were right. Well, it's a time. Okay, I mean, look at the text box, guys. You see this question is in the text box. It's just a matter of time management. I mean, it's not a super complicated answer. It's basically like, if you have time to mess around with that kind of thing, then you do, and if you don't, then you don't. I mean, I know it sounds like a cheap answer to that, but that's the answer. Like, if you have time to do it, you do it. If you don't, you don't. If you already sunk 2 minutes and change into the problem, then you just say, I'm done, I'm out of here, and you guess and you slam the door. But if you've only spent, 30 seconds, then you can pour some time into guessing. Well, time management is something we've talked about in other study halls. So if you want to, basically the deal is it depends on whether you're behind or not, but not really. I mean, you should pretty much have the same sort of, you should pretty much have exactly the same time management all the way through the test, unless you fall behind. Like, the worst thing you can possibly do is give yourself like more time at the beginning, for instance, because that'll kill you. But okay, in any case, let me show you one more thing about that problem. I know you guys are sick of this problem, but there's a backup method that I want to show you. In a study hall we did a couple of months ago, we talked about plug-ins. If you don't understand the algebra, then you can just plug in a whole bunch of examples and watch what happens. And that'll be good enough, right? Like if you keep getting this is a value question, it's not a yes or no. So if you just like plug in a bunch of lines, And then, like, if you keep getting the same x-intercept over and over again, then you would pick sufficient. And if you ever get two different x-intercepts, then you pick insufficient. Let me correct the spelling there. Okay. So let's try that. I mean, you just pick a whole bunch of lines that satisfy this equation, right? So let's just pick a bunch of lines with m equals 4 times b. So someone in the text box, someone put some equations of lines in the text box that do that. Give me the equation of a line whose slope is 4 times its y-intercept. 4x plus 1. Okay. 8x plus 2. Should probably check a couple of negatives. Should probably check maybe a couple of big numbers. Maybe some fractions. Okay. If all of these give me the same x-intercept, then I'm going to be convinced. So remember how to find x-intercepts. X-intercept is you plug in 0 for y. So these are all zeros on the left. If you solve these, for the first one, you'll get x equals -1/4. The second one, you'll get x equals -1/4. For the third one, you'll get x equals -1/4. For the fourth one, you'll get x equals -1/4. For the fifth one, you'll get x equals -1/4. I don't know about you guys, but this is enough to convince me. So you should pick sufficient. If you don't understand the algebra, this is what you should immediately start to do. Because you would be surprised how many data sufficiencies will yield to this, where if you don't know what's going on, you just start volleying examples at it until it gives you the secret, basically. It's kind of neat. Any questions? Smiley face if you guys understand this. I mean, again, some of you are probably not going to be convinced to try this method, but notice that you don't have to have any ability to do this algebra to make this work. Like if you, so yeah, I mean, you can try this all the time. As far as why option E is impossible, why don't you email me, because the rest of the class gave me a bunch of smiley faces on that. So, you know, in order to conserve time, why don't you shoot me an email? Okay. Email address is here. Type in the text box. There's the email address. Okay. Let's move on. Let's talk about critical reasoning. Any questions? If you've got any questions about this coordinate geometry stuff, the takeaways from today's lesson about coordinate geometry, let's just cycle through these slides and let's go over that. Remember, it's algebra and it's visualization. These are both valid. You should probably try visualization first because it's pretty much either going to work or not, and that's going to be a pretty fast decision. But you should try them both. Okay, here's just an illustration of the different types of approaches you'll get with these. Some example problems, and also make sure you understand these guessing methods, especially what we said about the way the test is written. Okay, you should actually get to the point where, ironically, you're actually guessing against your first instinct if you have to guess. Okay, let's move on. Let's talk about critical reasoning prompts. All right, and what I mean by a weird prompt is something like this. It's not on the screen yet. What I mean by a weird prompt is, why is this thing giving me a hard time? Okay, by a weird prompt, I mean something like that. Okay, if any of you have seen this before, this is from OG, I think it's OG 12, problem 110. But whatever, I'm not going to reproduce the whole question here. The point here is that there are problems with very strange choices, or very strange prompt questions. So the goal of this unit, which is, the reason I'm doing this is because a few of you posted critical reasoning questions where you posted the whole problem, but the deal was just that you didn't really understand what they were asking you to do in the first place. So in order to kind of address what the main point, what the main issue is here, I've isolated out some weird statements from a bunch of these. But before you can do that, what you've got to do is first you have to have an absolutely formal understanding of what it is that you're actually doing in these critical reasoning problems. So before we start hitting up some examples of these, I've got 1, 2, 3, I've collected 8 examples for you guys actually, so that'll definitely take us until the end of the session. These time flies for these things. I can't believe we're already an hour and changing this thing. You've got to understand, first you've got to understand the different question types. Okay, so I'm going to do a really, really quick review of this just so we can start hitting up these prompts. Find the assumption. You've got to understand that an assumption is a statement that must be true. It's necessary for the argument to work, but not in the statement, not in the passage. In other words, if you reverse the statement, or if you remove or negate the assumption, the passage fails. Okay, smiley face if you guys understand that this is what assumptions are. Okay, that's what assumptions are. All right, draw the conclusion means the conclusion is a statement that can be proved from the existing statements, but is not actually part of an argument. And so this is, I mean, a lot of people confuse assumption and conclusion questions. The main difference is, I mean, they're both some sort of guarantee. Like an assumption, you need the statement, and a conclusion, you can prove the statement. But the biggest difference is that an assumption is a necessary part of the argument. It's not articulated, but it's actually a premise, whether it's articulated or not. The conclusion is not actually part of the argument. So if you remove the conclusion, then nothing happens, because the conclusion, by definition, is redundant. But here's the difference. These are things that you can derive from the passage. Okay, so an assumption is needed in the passage. It's not just some random statement. And then a conclusion must be true in the passage. The other kinds of questions are, the strength and weaken. All right, these statements, they either help or hurt the passage, but they are assumed to be true ahead of time, that they are treated as true ahead of time. If they're statements. We'll get there in a second. And here's the biggest thing. The biggest difference here is these are extra considerations. Like, they're not necessary. Absolutely not necessary for the argument. That's the biggest difference between a strengthener and an assumption. An assumption is an integral part of the passage, whereas a strengthener weaken is not. It's just some random statement that you treat as true and see how it helps. And the last type of question we got to understand ahead of time is the explain the discrepancy type question. This means that the passage presents some sort of thing that looks like a contradiction. Like, there are two things that don't appear to work together. And then you're looking for, again, it's an extra statement that reconciles these two things. It helps them get along. So notice one thing that's a big, big difference here is that explain the discrepancies and strengthen weakens. Evaluate the argument is not an issue, because if you're evaluating the argument, it's going to be really obvious that that's what you're doing. Like, it's the question in the text box is what I'm answering right now. Evaluating the argument, you're not going to have prompts that are hard to decode, because you know what those look like, right? Those answer choices they look totally different. The answer choices are not statements anymore. Like, the problem with the answer choices to these four questions look just like each other. They're all statements about the stuff in the passage. The answer choices to evaluate the argument is stuff like, the first statement is evidence against the position in the passage. You know, they're obvious. Like, you know what the question type is. It's not obvious how to solve it, but you'll have no trouble telling those apart from other questions. So, Greg, smiley face if you understand it. Okay, so we don't need to address that here. These are the ones where you can't just tell with a quick glance at the choices. And so this is the stuff that you need to know. So smiley face if you guys are okay with the basic facts that are on this thing. Okay. Vigas, the answer to that question would take several hours. I mean, there's no short answer to that. Otherwise, we would be very, very rich people. Okay, so let's look at some examples. Second here. Try this one. I've given you A through D choices. I'll give you about 20 seconds to look at this. See if you can pick what this is. Give me an A through D answer choice. Okay, go ahead and pick an answer. I think most of you are on the right track, but if you're in attendance here, go ahead and pick an answer, please. Okay, you guys did very well on this one. Here are the polling results. There are still some of you without answers, but this is pretty solid. This is a draw the conclusion type question. So, and that indeed the majority is correct this time. Because again, let's look at what we're doing. We're doing this. Must be true. Proved from the existing statements. That's exactly what's going on in this example. You're looking for something that must also be true, means that you're trying to prove the statement. From can be proved. And then if the statements above are true, that means from the existing statement. This is not an assumption, because assumption is going to mention something about an argument. Okay, let me go ahead and type that. Here's the difference. Draw the conclusion is just you're taking a bunch of existing statements and proving another statement. In fact, when you do draw the conclusion, there's not even usually an argument. I mean, this is the one type of problem where this usually has nothing to do with any sort of argument. You're just taking a bunch of factual statements. The passages for draw the conclusion problems are not arguments. They're just collections of statements of fact. So, and then you're just deriving another fact. So, whereas the way you can tell this is not an assumption question is that if it were, find the assumption completes an argument. You know, it finishes off an argument. Okay, smiley face, if that makes sense to you guys. The class did pretty well on this. So let's move on to the next one. Smiley face, if this is good. Okay, I see a lot of smileys. Let's look at the next one, which is right there. I'll clear out your answers. There's the next one. See if you can figure this out in 20 seconds, because again, in 20 or 30 seconds, because you got to be pretty fast at this stuff. Give it a shot. I know that you shouldn't be able to see each other's answers, but you guys are doing really, really well. So those of you who don't have the answer, go ahead and give me something. And then I'll publish it, statistics to the board. Okay, that was, here's your statistics. Pretty solid polling here. I'm going to get it out of the way of the question. Here's your statistics. Class is correct again. Nicely done. It's like playing that game show where you ask the audience. It's kind of neat. This is a find the assumption question because again, look at what you're doing. It says if the conclusion of the above argument. Remember that this is for those of you who picked B here. There's a couple of you. This purple box proves that it is not B. Because draw the conclusion, you don't have an argument. I mean, this means that you already have an argument that already has a conclusion. So your job here is definitely not to draw another conclusion because that would make no sense. So this is not B. If it is to be properly inferred, well, if we translate that, let's see what that means. In order to make the argument work, and then which one of them must be true, what do we need? Which one is necessary? So that is the definition of find the assumption. statement that is necessary for the argument to work. It's needed to make the argument function correctly. Any questions about this one? Type them in the box. Give me a smiley face if you are ready to move on. Okay, they're going to get more obnoxious. So try this because I love you guys that much. I gotta black out the other one. All right, try that one. I'm gonna clear out your answers. See if you can do it in 20 or 30 seconds. This one, by the way, this one's not fun, but give it your best shot. Okay, this one's, like I said, this one's a little bit more obnoxious, but give it your best guess. Make sure you try to, a few of you all-stars have this right. If you're, I don't know what it is, the people that whose names start with A, you all got this one right. Maybe it's because you're guessing your own initials or something like that, or you're just really that good. This is actually another find the assumption question. So let's talk about why. This one's probably the most obnoxious prompt that I've seen. So if you missed this one, I wouldn't feel too horrible about it. But this is A. This is another find the assumption question. Let's talk about why. You got three components of this prompt. And let's see what these mean. So if we put those colors together, an objection to an argument means that the argument is faulty or it fails. So the purple means that the argument, smaller font size here. The purple means that the argument is faulty. If the statement is negated. Doubts about the truth. That means if the statement is untrue, then, and so this is just a really obnoxious way of saying if you negate the statement, the argument becomes faulty. Well, that's what an assumption is. An assumption is something that if you remove it or take it away, the passage goes belly up. So not easy. This, again, like I said, this is probably the single hardest prompt to understand that I've seen on this test. But tried color coding it for you. Faulty if the statement is false. Give me a smiley if you understand that. So to find the assumption question. And I mean, this is also, a couple of sessions ago, we did this thing called a reversal method. This also ties in with that reversal method. Okay, on to the next one. Try, this one's really common, by the way. So I'm going to black out your answers again, and then this one is especially important. So, because it comes up a lot. Go for it. Okay, if you don't have an answer indicated, try to guess something. Let's talk about this one. Here's your class statistics. All right, you guys were all over the board on this one. Like there's no clear majority of anything. So this is good because you really got to understand what's going on here. I'll give you an example because this is important enough. I'll give you an example on the next slide. But here's what's going on here. What does evaluate mean? I mean, that's key. Type in the text box if you know what evaluate means. I mean, that's a big, big, big part of that. It is no, it's not conclude. That's not what evaluate means. To find out, yeah, there you go. Find out if it's good or bad. That's what evaluate means. Basically, to tell whether it's good or bad, aka strong or weak. There's your hint of the day. And then which one of the following must be studied? What this tells you is that you're looking for something that's external to the passage. So you want something that is external to the passage. So you're looking for something external to the passage to tell whether it's going to strengthen or weaken the passage. All right. So that is going to be a strengthen or weaken question. They're external to the passage, and they help or hurt. So let me give you an example of how they do this. Okay, here's a stupid little passage. I have, let's say, 9% body fat, and then my friend also has 9% body fat. Therefore, my friend and I both have the same number of pounds of body fat. Does anybody see where the problem is in this argument? If you do, go ahead and type it in the text box. Yeah, exactly. It's a percentage versus a weight. So it depends on the weight. Now, here's the deal. If you wanted to strengthen the conclusion, if the question was which of the following strengthens the conclusion, we have the same body weight. Which of the following weakens the conclusion? This would be we have different body weights. Now, what they're going to do if they ask you this weird question that's like, which of the following would be useful or must be studied in order to evaluate the argument. The difference with this is that it doesn't tell you whether you're supposed to strengthen or weaken the argument. So what they do is they're going to give you a prompt that's like this. You're going to have whether we have the same body weight. But that's how they're going to do this. So you can't tell if it's strengthened or weakened, but it's one of the two, depending on how it turns out. It's either strengthened or weakened, depending on the outcome. So that's how this works. But you definitely should recognize, smiley face if you guys follow the way they're going to do this. The way this works. Smiley face if you get that. It's not a statement to reconcile because there's no contradiction here. I mean, there's nothing here that seems to contradict something else. So that's how they're going to do this. Okay, a couple more minutes. Let me give you two more. Let's see. Yeah, you'll have questions that say which strengthen it. Okay. Try the following. Need two more. Try this one. Okay, I'll clear out your answers again. By the way, no answers in the text box. There's buttons on the top left of your screen, so use those, please. Okay, let's pick something here in the next couple of minutes. Question, well, are you looking for verbs in the stem? Well, it depends on what you're looking for. What you're looking for is something that agrees with one of those 4 types that we were talking about. And one thing you can do, if you're up to it, is you can just sort of memorize what we're looking at today. I mean, you can, the prompts that we look at today, you can just sort of remember which ones look like what. I mean, that's a lot of words, but, you know. Okay, so here are your statistics. This is the next to last problem of today. Here's your statistics. This one actually accounts for the findings of the experiment. Well, here's a question. I mean, when would you have to account for the findings of an experiment? And when would you have to do that? I mean, you would only have to account for findings if something were surprising or unexpected. So, I mean, otherwise you don't have to bother accounting for. Like, I mean, you guys, like, think about when they ask you to account for something. Account for means explain. So this is not a conclusion, because that's not what conclusions are on this test. Conclusions are things that can be proved. So you're not, by definition, when you do this, you're not proving anything. So it's not a draw the conclusion problem. Hypothesis means that it's definitely not proved. It means it's a guess. It's an external guess. It's not proved. So it's not a draw the conclusion question, and it's a hypothesis, so it's not an assumption either. Because an assumption is something that has to be true. This is a random guess. By definition, a hypothesis does not have to be true, so it's not an assumption either. What it is it's one of these guys. It's one of these explain the discrepancy things. Because you've got some sort of surprising or unexpected findings that you need to explain, and you need some sort of external guess that will actually do that. All right, we're a little bit over time here, but let's do one more. There's a question in the box. If you type that pretty quickly, I can nail it. Otherwise, we'll do one more of these things. This one's probably a little bit more straightforward. We'll get the rate time distance in the next. There's always more of these study halls, you guys. So, okay. So, well, part of it depends on student submissions. I mean, I think I got 0 sentence corrections submitted to me in the last couple of weeks. So, okay, try this one here. Last one of the day. Clear out your answers. Go for it. Okay, let's do this. Which of the following were inserted as an additional premise? This one you could there's 2 ways you could do this. This one you could actually interpret as either a strengthen or a find the assumption question, but it's probably better to answer this as a strengthen question because it does not say it has to be true. So you guys are right on with this one. Nicely done. Notice that it doesn't say it's necessary. So it's just were inserted as an additional premise. So it doesn't have to be true, i.e. it's external and doesn't have to be true. So this is a strengthen question. All right, so I hope that gives you a little bit of a head start on these things. By the way, just memorizing what we've seen here, like in all these problems that we've looked at, is also a perfectly valid way to go, although hopefully you're trying to understand it also in terms of these items. So if we go back to this, we didn't get to this today, so this is going to be in one of the next study halls, probably the next study hall. So this will go to either 415 or 420. That's very tentative. If the 415 study hall is verbal, then we'll do this 429. If not, we'll do it on 415. Just depends on what we get, submissions, stuff like that. So nicely done. I got to run here. If you have quick questions, you can shoot me an email. It's going to depend on what people submit. I mean, I try to make them balanced. I try to make it about half and half overall. Not each session. I mean, most sessions are majority verbal or quant. But I try to make it overall even out. It's kind of like our 9-session course. I mean, you guys know there are some sessions that are almost all quant. There are some sessions that are almost all verbal. But overall, it is what it is. Okay, so let's kill it. I've really got to run, so if you guys can quit the application in the next couple of minutes, that'd be fantastic. If not, I'll start logging you guys out. Recording's going to stop right now.